Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 18.2, which is going to deal with volume of pyramids. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to find the volume of a pyramid. So we're going to talk about what pyramids are, and then how to find the volume of them. Now, in section 18.1, we talked about prisms, okay? Whether it was a rectangular prism or a triangular prism, we talked about how to go through and find the volume of these shapes. So, to find the volume of a prism, we had to find the area of the base, in this case a rectangle, or in this case a triangle, and then multiply it by the height of the prism. Now, prisms have a base on the top and on the bottom, and the sides are made up of rectangles. Okay, same thing for a triangular prism. Base, top and bottom is triangles, and the sides are all rectangles. Now, today we are focusing on pyramids. So a pyramid is going to have one single base, and then the sides are going to be made up of triangles, and they're all going to meet at one point at the top. So this is called a triangular pyramid, where the base is a triangle and the sides are all triangles. A rectangular pyramid has a single rectangular base, the sides are all triangles, and much like a triangular pyramid, like with all pyramids, they all meet at one point at the top. So a pyramid has one base, whether a triangle or a square. The sides are all triangles, and they fold up to meet at one point at the top. Now, triangular pyramids and rectangular pyramids is where we're going to spend most of our time today on finding volume. But we're also going to talk about how you can find the volume of a pentagonal pyramid, where the base is a pentagon, and then it has the rest of the properties of a pyramid. And then you can also have a hexagonal pyramid, where the base is a hexagon, and again, the sides are triangles. So, that is what a pyramid is. Let's talk about how we go through and find the volume of these pyramids. So, most of our time is going to be spent talking about rectangular pyramids and triangular pyramids. So, with that said, let's go ahead and talk about this volume formula for pyramids. So, our formula for today is going to be as such. The volume of a pyramid with the base area B and the height h is given by V equals 1/3 capital B times h. So, what you have to do to find the volume of a pyramid is you have to find the area of the base. So if we're talking a rectangle, find the area of this rectangle, figure out the height of the pyramid, and once you have the area of the base, the green part, the height of the pyramid, then you can plug it into 1/3 B times h. So similar to a volume of a prism, except we're adding in 1/3. All right, so V equals 1/3 B times h. That is our lifeline for today's notes. And that is what we're going to use to help us answer questions for example 1. Now, example 1 wants us to find the volume of the following pyramids, round to the nearest hundredth if necessary. So we're going to go through, find the volume of these pyramids, and when we get to the end, we're going to round to the nearest hundredth 2 decimal places if we need to. So, with that said, let's go ahead and take a look at example 1, part A. So our pyramid for example 1, part A is a rectangular pyramid because the base is a rectangle. Okay, so we have to go through and find the area of this green part, this rectangle, and then we can use the height of the pyramid to help us find the volume. So, the base is this purple shaded area right here. We need to go through and figure out the area of that section. Now, because that base is a rectangle, to find the area of a rectangle, it's length times width. So the length of this rectangle is 24, and the width of this rectangle is also 24. So we're going to do 24 times 24 to find the area of this base. So if we use our calculator, we do 24 times 24, we end up with 576. So 576 centimeters squared is the area of this rectangular base, that purple shaded area. So now that I have the area of the base, this is where we bring in the volume formula. So to find volume of a prism or pyramid, it's 1/3 times the area of the base times the height of the pyramid. So we already have the value for B, the area of our base, which is 576. The only other thing we need is the height of the pyramid. Now the height of the pyramid, they tell us through right here, is 16 centimeters. So if we plug everything into the formula, that's V equals 1/3 times area of the base, which is 576, times the height of the pyramid, which is 16. So I have 1/3 times 576 times 16. All we need to do from here is just plug it into our calculator and figure out our volume. So 1/3 times 576 times 16 gives us 3,072 centimeters cubed. And that is the volume of this pyramid. So it's 3,072 centimeters cubed. Remember, it's units cubed because we are talking volume, not area. And that is how you go through and find the volume of a pyramid. So, find the area of the base. Once you have the area of the base, identify the height of the pyramid, and then just plug everything into 1/3 B times H. Alright, so with that said, we're going to go ahead and practice a few more, so that way you have a few more examples to reference on the homework. Next one, for part B, again we have a rectangular pyramid. And it's a rectangular pyramid because the base is a rectangle. So we had to figure out the area of the base, which in this case is a rectangle. So to find the area of a rectangle, it is length times width. So the length of this triangle is 230, and the width of this rectangle is 230. So we're going to do 230 times 230, and that is going to tell us the area of this rectangular base. So, using our calculator again, if we do 230 times 230, we end up with 52,900. So the area of this purple base is 52,900. Alright, now that we have the area of the base, we can bring back our volume formula, which is 1/3 times the area of the base times the height of the pyramid. So the area of the base is 52,900. So that's 1/3 times 52,900 times by the height, h, of the pyramid. And the height of the pyramid is 146. Now that I have everything plugged in, we can just go through and type this into our calculator and figure out our volume. So 1/3 times 52,900 times 146. And that gives us 2,574,466.67, because we want to round to the nearest hundredth, which is 2 decimal places. So this is going to be 2,574,466.67. 2,574,466.67 meters cubed. And that is the volume of this pyramid. So find the area of the base, figure out the height of the pyramid, plug everything into the formula. All right. So that's 2 examples on how to go through and find the volume of a pyramid. Let's go ahead and move on to parts C and D, and then we want to wrap up with E and F because they are a little bit different than what we will have done for A through D. All right, for C, yet again, we have a rectangular pyramid, meaning the base is a rectangle, so we need to figure out the area of the base. And remember, to figure out the area of a rectangle, it's length times width. Now, the length of this rectangle is 2.5 centimeters, and the width of this rectangle is 1.5. So it's going to be 2.5 times 1.5. So, using our calculator, if we do 2.5 times 1.5, we end up with 3.75. So the area of this purple base, this rectangular base, is 3.75 centimeters squared. All right, so now that we have the area of the base, we can then go through and use the volume formula, which is 1/3 times the area of the base times the height of the pyramid. So we now know the area of the base is 3.75. So it's 1/3 times 3.75. And then the height of the pyramid is 1.5 centimeters. So end it with times 1.5. So from here, we just need to use our calculator. So if we do 1/3 times 3.75 times 1.5, we end up with 1.875. And because they want us to go to the nearest hundredth, that's 2 decimal places. So this is going to be 1.88 centimeters cubed. And that is the volume of this pyramid. All right, so we've gone through and done a series of examples on rectangular pyramids. Let's talk about how we can go through and find the volume of a triangular pyramid. So a triangular pyramid means that we have a triangular base. So for the pyramid in part D, if you notice, the base is a triangle. So what we need to do is figure out the area of this triangle. Once we know the area of the triangle, then we can go through and find the volume like we've done for all the other problems. So, first step is to find the area of the triangle. Remember, area of a triangle is 1/2 base times height. The base of this triangle is right here, which is 15.2, and the height of the triangle is 12.5. Base and height can be interchangeable for this because it's a right triangle in that corner. So 1/2 times 12.5 times 15.2. If we use our calculator for this, we do 1/2 times 12.5 times 15.2, we end up with an area of 96 millimeters squared. So 96 is going to be the area of our base, our triangular base. So now that I know the area of the base, we just use our volume formula to plug everything in. So it's 1/3 times the area of the base, which is 96, times the height of the pyramid, which is 8.1. So they tell us the height right here. So now that I have everything plugged into the formula, we just have to go through and calculate. So 1/3 times 96 times by 8.1 gives us 256.5, and that is the volume of this pyramid. Sorry, not 256, 259, I apologize. So 259.2 millimeters cubed. And that is how you go through and find the volume of a pyramid when given a diagram. All right, so that is A through D. I do want to take a look real quick, though, at parts E and F, solely because they don't give us a diagram to go off of, but they tell us some information. Now, for E, they tell us that we have a pentagonal pyramid, and for F, they tell us that we have a hexagonal pyramid. That means the base is a pentagon for E, and that the base for F is a hexagon. So 5-sided base, 6-sided base for E and F respectively. Now, whenever you deal with any base that is more than a rectangle, so a pentagon, a hexagon, a heptagon, and so on, they will tell you the area of the base and the height of the pyramid. Reason being, it is a pain to find the area of a pentagon and the area of a hexagon. So they're just going to provide you with that in the description. So for E, they tell us a pentagonal pyramid with a base area of 25 feet squared and a height of 9 feet. So what they have done in this description is told us the area of the base and the height of the pyramid. The two things I need to know to plug into our volume formula. Same thing with F. They tell us a hexagonal pyramid with a base area of 24 over tan 30. So this is our base area. You can see how much of a pain it would be to figure out area of a hexagon. And then the height of the pyramid, our h, at 4 times the square root of 3. So they tell us the area of the base and the height. So all you have to do for these problems is just go through and plug those in to your formulas. So volume equals 1/3 times the area of the base, which is 25, times by 9. Same thing with F. Volume equals 1/3 times 24 over tangent 30 times by 4 times the square root of 3. So E looks a lot more palatable than F, but I promise once you plug everything in, you will be more than fine at the end. So let's go through and calculate E, and then we'll take a look at F. So for the pentagonal pyramid, it's 1/3 times 25 times 9. And when we type all of that in, we get a volume of 75 feet squared, or cubed. And that is our answer for part E. Alright, now for F, we have the fun task of typing this all in. I would suggest probably not typing it all in at once, but go through and evaluate different parts. One thing to note, as we talked about in the trig unit, please make sure your calculator is in degree mode. If you want to double check that your calculator is in degree mode, if we type tangent 30, you should get 0.57732 and so on. If you do not get that number, you're not in degree mode and you need to change it to degrees. So I'm going to suggest that we evaluate this 24 over tangent 30. So it's 24 divided by tangent 30, and that gives us 41.569, so on. Let's multiply that by 4 times the square root of 3, and that gives us 288, and then we want to multiply by 1/3, and that gives us a volume of 96 units cubed. So, while it may seem awful, okay, it does work out in the end a lot nicer. So, whenever you are given a rectangular or a triangular pyramid, they're going to give you a diagram like A through D. Find the area of the base first. Once you have the area of the base, figure out the height of the pyramid and then plug everything into 1/3 times the area of the base times the height of the pyramid. So that's what you would need to do if they give you a diagram. Find the area of the base, figure out the height, plug it in. Anything that is going to be beyond a rectangle that has a base more than a rectangle, so a pentagon, a hexagon, and so on, they will tell you the area of the base, and then they will tell you the height of the pyramid. You just have to plug everything into the formula. 1/3 times B times H. So that is how you go through and find the volume of a pyramid for section 18.2. Now, on the other side, on the back side of the notes, example 2 has us go through and deal with composite figures. So it's either a pyramid on top of a rectangle, or it's a pyramid removed from a prism. So parts A and B, it's a pyramid removed from a prism. For C, it's two pyramids on a prism. And then for D, it's two prisms combined together. So example 2 wants us to go through and find the volume of the composite figures and round to the nearest hundredth if necessary. The goal and the way to go through and do these problems is find the volume of each shape involved and then go through, because it's removing for A and B, you subtract. For C and D, because you're combining, you're going to add them together. So I'm going to go through and do a few of these for reference as well. All right, for the first one, for example 2a, we have a pyramid removed from a prism. So that means we have a prism and we're going to take out the volume of a pyramid. So it's kind of indented in. That's what this is indicating here with the dotted lines. So what we need to do is figure out the volume of the prism, figure out the volume of the pyramid, and then subtract those two numbers. All right, so first thing we need to do is figure out the volume of the prism. So let's start there. Now, to find the volume of a prism, this is back to 18.1. Volume of a prism is area of the base times the height. Or in this case, length times width times height. So, the length of the prism is 25, the width of the prism is 12, and the height of the prism is 15. So we're going to do 25 times 12 times 15. So we're going to go through and multiply those three numbers to tell us the volume of the prism. So 25 times 12 times 15 tells us that the prism is 4,500 feet cubed. All right, so I now know the volume of the prism. The next thing we need to do is figure out the volume of this pyramid that is being removed out of the prism. So a pyramid is 1/3 times the area of the base times the height of the pyramid. So the base of this pyramid is a rectangle. Area of a rectangle is length times width. So let's go ahead and figure that out real quick. So length times width. The length here is the same here, so 25. And the width here is the same here, which is 12. So we're going to do 25 times 12. So if we do 25 times 12, we get 300. So the area of the base of the pyramid is 300. All right, so now that I know the area of the base, we can go through and plug this in. So that's going to be 1/3 times 300 times the height of the pyramid, and that's going to be the same height as the prism. So that's going to be 15. So what we're going to do is calculate this through. So 1/3 times 300 times 15 gives us a volume of 1,500. and that tells us the volume of the pyramid. So now that I have the volume of the prism, now that I have the volume of the pyramid, because it's being removed, unlike what we did in the 18.1 notes where we added them together, we're going to take these two and subtract them. So the total is going to be 4,500 minus 1,500. So if we do 4,500 minus 1,500, we get 3,000. So 3,000 feet cubed is the total volume of this composite figure. Now, if the pyramid was on top of the prism, we would add these together, and that would give us a total volume of 6,000. But we're removing it, so we have to subtract it away. So that is how you go through and find the volume of composite when you're removing a shape from it. And that is going to be the same thing that you would do for part B. So next, let's take a look at either C or D to finish off our notes for today. All right, for C, we have two pyramids on a prism. So we have one prism, which is the base, and then two pyramids on top of our prism. So we need to go through and figure out the volume of the prism and the volume of both pyramids, and then add all three together. So let's go ahead and start with the prism, since that's the one that we're most used to. So for the prism, this rectangular prism, it is volume equals length times width times height. Now, the length is 10, the width is 5, and the height is 2. So we're going to do 10 times 5 times 2. And that's going to tell us the volume of our prism. So 10 times 5 times 2. And that gives us a volume of 100. All right, so I now have the volume of the prism. Now we need to go through and figure out the volume of the pyramids. Now, for volume of a pyramid, it is 1/3 times the area of the base times the height of the pyramid. So, the base for both of these pyramids is squares. Now, when we're talking about area of squares, it's length times width. This side right here is 5, and this side right here, because we're cutting it in half, is also 5. So this part is 5, and this part is 5. So it's going to be 5 times 5, which gives us 25. Now, this one's 5 times 5, and the same thing is the case for this pyramid. It's 5 times 5. So both pyramids, the area of the base for both pyramids is 25. So it's going to be 1/3 times 25 times, they tell me the height is 3. So we can go through and calculate the volume of this pyramid, and then we'll go through and calculate it for this pyramid. So 1/3 times 25 times 3 gives me a volume of 25. Now, this pyramid has an area of the base of 25 because it's 5 times 5, and its height is also 3. So the volume of this pyramid is the same volume of this pyramid, which is 25. So pyramid number 2 is 25 units cubed as well. So to figure out the total volume, because it's a prism with 2 pyramids on it, means we're adding it on top. So we're going to take the volume of the prism and add it by the volume of both pyramids. So if we do 100 plus 25 plus 25, we end up with a volume of 150 feet cubed. And that is our volume for part C. All right, now for part D, so they give us 2 pyramids. They are the same pyramids on the top and on the bottom. So your goal is to go through and figure out the volume of one rectangular pyramid that's the same volume on top as it is on bottom. So then you just have to add those 2 numbers together, and that would tell you the volume of this composite figure. So I will leave that one for you guys to run through and do on your own. If you want to make sure you're on the right track, after you figure out the volume of both these pyramids, again, they're the same, you should get a total volume of 192 inches cubed. Okay, they tell you the side lengths and the height of the pyramid. So the side length is 6, and then they tell you that the height of the pyramid is 8. So I will leave D for you to do on your own. Again, find the volume of both those rectangular pyramids and then add them together. So with that said, that is it for today on our notes for section 18.2 on finding the volume of pyramids. Remember, pyramid has a single base, the sides are triangles, and they all meet at point. The key for your stuff today is to know the volume formula of a pyramid, which is 1/3 times the area of the base times the height of the pyramid. This is important. Okay? So, with that said, that is it for today's notes for section 18.2. As always, if you have questions, please do not hesitate to let me know, or send me an email, or just let me know the next time you see me. I'll be more than happy to help however I can. So please reach out if you have questions on the notes, or if you have questions on the homework. Be sure to reference back to this video or my completed notes, as I have all of the examples done, so you can see my work there, and it would provide you with an example while you work on your homework. Also be sure to use the examples on the homework as well. So, with that said, thank you guys for listening. I hope this video was helpful, and I hope you feel comfortable with this. Good luck in your homework. Let me know if you need help. Otherwise, have a great day, and I will talk to you guys later. All right, bye.